Assume that a sample is used to estimate a population proportion P. Find the 95% confidence interval for sample size of 249 with 32% successes. I'm going to show you two ways to do this. The first way is using the LibreText calculator. And before we do that, let's just write down what we know here. Our sample size N is 249. Our P hat is the probability of success, that's 0.32. X is the number of successes, that's 32%, 0.32 times 249. And that's 79.68. However, since X is the number of successes, that needs to be an integer value, so we're going to take X to be 80. All right, let's check the requirements for constructing this confidence interval. The requirements are that NP hat and NQ hat should be greater than 5. Q hat is 1 minus P hat. So that's 0.68. And both of those numbers, when I do that multiplication, are greater than 5, so we're good to go. So I come over here to my list of calculators, and I'll have a link to this list in the problem. And you're going to scroll down till you get to confidence interval for proportion. And then enter what you know. N is 249. X is 80. Confidence level is 0.95. And hit calculate. And there it is. And let's record those numbers to 3 decimal places. Over here, this would be P between 0.263 and 0.379. And it's that easy. Now, if you want to do formulas to do the problem, use formulas, then you're going to use error bound is z sub alpha over 2 times the square root of P hat Q hat over N. And then your confidence interval is formed by taking that number and subtracting it and adding it respectively to P hat. For a 95% confidence interval, z sub alpha over 2 is 1.96. And I'll show you how I get that. For 95% confidence, the area in my standard normal curve in the middle is 0.95. And so the area of the tails is 0.05 added together. So each tail has area 0.05 divided by 2. And that is 0.025. So if you come back over to your list of calculators here and select normal probability, you can compute that value and you'll see how I got 1.96. The area in the tail should be 0.025. Standard deviation's 1, mean is 0. Click greater than because we want the right tail and calculate. And there it is. To 4 decimals, that's 1.96. Okay, so let's come back over here. After we have that, it's just a matter of putting these numbers into our calculator to get the error bound. The error bound is 1.96 times the square root, 0.32 times 0.68 over 249. And when I do that, I get approximately 0.0579. And so to get my confidence interval, I take that number and subtract it and add it to 0.32 P hat. And that's what I did here. And I get that interval there. And that's it.